Hey guys, and welcome back. So after we looked at the deforming surface idea, I wanted to explain how this is working in SOPs and why I did it in SOPs. Well, the main reason is I wanted more control over the various layers, and I wanted a different curvature, different shape that I wasn't able to get with a soft deform. And you see, I can easily control that ripple and how much it goes up. It's pretty much fully controllable. This is quite easy at this point and should be very accessible to all of you guys, but I want to quickly explain the idea and then I will take a look at the setup and show you what I did. So what we want first is we have this grid which is at 0, 0, 0. Okay, so that's important. And then I'm going to compute the length of the point position and fit range that between 0 and 10, and let's plug it in. Okay, so we have a ramp, and let's check the size of the grid. So it's 13 and 10 is fine, so I'm gonna swap the input. And we have this. So let's reduce. I don't want to get to the boundary, so I'm going to set this to 5, and that's going to be my my ramp. And what I want to do is I want to change the Y position of all these points and drive them using this map. So I'm going to use a set vector component because I want to change the Y position only. I'm going to plug this in. Say I want to change the second component, which is the Y, and then I can plug this map. And that's going to be my new position. And you can see how it's looking. Let's turn this off. You can see how the map is looking. So what we can do is, instead of pushing upward, we can invert this. So I'm gonna multiply it by -1, multiply by constant, -1, and now it goes down. Cool. So now with this, I have full control over the shape, and I'm going to use a ramp node, and I'm going to change it to a float, and let's go up, and this is the default, nothing changed, and we can change this now to Catmull room, and now we have a lot more control. So let me check which I use the B-spline. Okay. So let's look at the front here, and this is what I care about. I'm gonna do the same thing, B-spline here, B-spline here, and now we have a different interpolation, and we can add a couple more points, and we can easily control the ramp the way we wanted it to be. Okay, so we have that, and then we need a driver to control the amplitude of this. So I'm going to create a multiply, a global multiply, and I'm going to promote this and call this height. And then if we play with this value now, we have the height. Okay, so we have one more thing that we need, which is the radius of this, and that is coming from this. The fit range is what controls the size of the circle, because we're simply computing the length and then we're refitting that. So here I'm going to promote this, not the min, the max, and I'm going to call it radius. And let's see, we start off at 5, we'll start at 0. I'm gonna do a quick test. So height is 0, radius is 0 for both. Then as we go, I'm gonna increase the height and the radius at the same time, something like that, and maybe the height lower. So this is one key, and then I go to frame 48, increase the radius to 5, and then the height more. So something like that. Increase it to something like that, and let's key them. And now if we look at the front, we should see it doing that. That's basically what I was looking for. Now the second part is the shockwave, the ripple, and it's very similar in terms of idea. It's pretty much the same. The only thing is I'm adding another push to the surface. So I'm going to copy this, and I'm going to call this radius 2, and this is going to be ramp 2, and it's spline as well. And here, instead of multiplying it by -1, I'm going to leave it, and I'm going to add it here, and this is going to push everything up, and I'm going to add a multiplier again and promote this. So this is going to be, I'm going to call this ripple height. And this is going to be ramp ripple. Okay, let's go up. So let's say 1. Okay, I don't need it to be 1. Let's go to frame 40. And you can see already that we have a different shape now. And if I add this, it's going to push the surface. Okay, I need one more thing. I want to expose the radius, make sure it's there. So the radius is here, radius 2 is here. So I'm going to make the second one bigger. And you can see what kind of shape we're getting now. But I don't want it to be too high, so just a tiny bit. Something like that. And I'm also going to change the curvature of this. So let's do this. Okay, so it starts at 0. Sorry, let me fix it. It starts at 0. It starts here at 0 as well. I'll just have this so we can see it. Sorry, this is here and here. And then the second keyframe is going to be bigger. And I'm also going to increase the height so we can see it clearly. And that's our surface, and then the second one. That's it. That's really all there is to it. The second layer from here is a different mask that uses the radius as well. So it uses the center and expands, and that mask is used to blend shape between this result and this result. And let me do it quickly here as well, just to show you. So point VOP, or a noise, I'm going to copy the same noise. And this is the first node, this is the second node. I'm going to dive inside. I'm going to delete all this. I don't need it. I only need this part. I'm going to transition using a linear transition. So let's import the second input points. Okay, ptnum is the same. And I'm going to mix between this and this using my ramp. Okay, let's invert this ramp. And now if we go up, we have this radius that we can use. And you can see we're blending between the two. And that's our last control. As it expands, I'm simply adding the noise. With the ripple, it's also the same mask that I'm using for the ripple, I'm using to drive the noise in between. And then all of that goes into this, which looks like this in the final surface. Okay, so let's plug this here. I want to use the new result. This is what we did together. and it's also very similar. So that's the idea. We create some noise, mask them, create a ripple effect, and then use it to drive a static RBD, a static packed primitive, and use that to be the driver for the collision. That's it. Thank you guys for watching, and see you in the next video. Bye bye.